Thank you for coming. The room is quite crowded. It's a great honor to be here. I would like to discuss here some lessons I have learned during my career about how to keep your project from disintegrating. My name is Martin. Some background about me: I'm a C++ developer in Exasol. Exasol is provider of fast in-memory analytical database solution with headquarters in Nuremberg, Germany. And in my free time, I'm volunteer for and a manager for a small NGO. Our NGO runs a small family farm. We are educating children and we are helping people with disabilities. We have employees with schizophrenia and mental retardation. And we also try to help animals. I'm also a horse trainer and horse coach. And I try to bring together words of horses and men, which are quite different. This gives me some background into how different creatures and beings think about the world. I'd like to start with a warning. This presentation might be a bit controversial. It contains a lot of my personal opinions, and you are very welcome to disagree with me after the presentation and questions. I always try to assume that other people know something I don't, and then I can learn from them. So I want to open with a question. Who do we write the code for? What is our audience? Because as programmers, we are writers. We produce a lot of text. And though I doubt somebody ever printed their Git repository and published it as a book, I really believe we are writers. So what's the target audience? Is it compilers and optimizers to parse our code? Is it processors to execute the compiled binary? Or is it programmers to read and hopefully to understand the code written? I can tell you a short story about a company which acquired another company, and in this acquisition it inherited a backend system. The backend system existed only in the form of deployed binaries. There were no source code, no documentation, and the people who knew what it did left. So what is such a system good for? I think it's good for nothing. It had to be rewritten from scratch. So the programmer is the key part in this equation. So what can we say about programmers? Our audience. Well, programmers are human beings. They have their motivations, they have goals, feelings, and ego. They are lazy and they have their habits. They don't like to change those habits usually. And they don't like being wrong. And the thing I'd like to start with, they are not good with handling complexity as any human beings, right? But wait, programmers are supposed to be smart, right? They are. But generally, I think the humans are really bad at complexity. Our perception is limited in the number of ways. So I'd like to try to answer a question. What's the depth of human mental stack? How many things we can store in our memory simultaneously without losing track of them? How many registers do we have? So I want to invite you to an experiment here. I'm going to show you images with number of squares, and I want to ask you to count them in your mind and focus on the counting process. Do you just look at the image and instantly know the number of squares there, or do you need to do some mental gymnastic to find out? One, trivial. No problems. 2, 3, 4, 5. 6. 'Here's the trap. 6 again. And 7. Now, for me personally, the boundary is between 5 and 6. I can look at the image of 5 and I just know the number. When I see the image of 6, my mind splits it into 3 and 3. And I can manipulate the way how my mind splits it to this divide and conquer algorithm. If I introduce a gap in between, this one got split to 4 and 2. But it still got splits. Is there anyone in the audience who can just look at this and know the number is 7? 1. Congratulations. You have exceptional mind.
I'm a mathematician.
The answer was that from audience that the gentleman is the mathematician, so good for him. So, one more experiment to show you the limits of human perceptions. I'm going to show you an image which is made of white rectangles, and I want to ask you to count them, to count how many rectangles did I use to create the image. Not how many rectangles can you find in the image, but how many rectangles did I use to compose it. So, ready? Great. The correct answer is 6, and it becomes clear when I change the coloring. You can easily verify that I used 6 rectangles to create this image. Now, while we were counting, how many of you noticed that I changed the background color from green to orange? About few people did. Not everyone who missed it. Good, thank you. About half of the audience, from what I can guess. This is a test designed by a prominent experimental, well, not this one, but it's inspired by a test designed by a prominent experimental psychologist, Daniel Simons, who, with his test, The Monkey Business Illusion, it demonstrates that while we focus at some task which might be difficult, we tend to ignore the rest of the environment. So, what are the results? How good are humans with handling complexity? This is, well, we can hold about 5 things in our memory. We can focus on one complex task and mostly ignore the rest. And to compensate these limitations in complex environment, we rely on number of simplifications. We rely on what we learned, our knowledge. We rely on habits we learned, and we rely on expectations. When we approach new things, we always have some expectations about it. It's almost impossible to live without them. And this is really important. Why am I telling you all this? This is C++ conference, not a psychological workshop, right? Because C++ is one of the most complex ecosystems out there. It's several languages put together, and the quality of code really matters. Have you ever seen a function call like that? Yeah, I believe everyone in this room did. Any ideas what those parameters might be? Well, we would be just guessing. There's no way of telling. So we need to look up the declaration of the function and that it becomes somewhat more straight. But this is another step the person has to take to understand the call. And it takes one register or one step of their mental stack. So they have to devote to it their emotional energy, and they have less energy tackling the problem they are trying to solve. So, with this in mind, I'd like to take a look at some recommendations which are widely accepted as a good code quality. This is reducing repetitions is one of the basic rules taught in computer science classes and advocated by many senior programmers like Guy Davidson, who I have huge respect to. But I believe it can be counterproductive in some cases. Actually, it happened to me because repetition reduction always costs you some increase of complexity, and the code becomes harder to modify. To demonstrate that, let's say we want to simulate an animal. We have a cat. Cat likes to look at your door, then eats a mouse, and then goes to sleep. And we have a dog, a different animal. Dog barks, then eats your dinner, which you left on the table, and then it goes to sleep. Now, there are clearly some repeating parts, so we, as we are taught, want to reduce them. And therefore, we devise an abstraction, which is a pet, and it takes a bunch of parameters, and we can use this pet abstraction to reduce the code duplication by delegating the call from cat and the dog. Pretty straightforward, right? Now, what's the problem with this approach? Let's say we want to introduce a new animal to our little family, a puppy. A puppy is a little bit different animal, as every dog owner can agree with me. It first eats your shoe, then it eats your dinner, and there's a part of your apartment before going to sleep. So this code doesn't quite fit to the abstraction we have here. And it could be fine. If we are authors of the previous code and of the abstraction, it's completely okay. But imagine the previous code was written a few years ago, and now you have new intern coming to your company, or your new colleague who is tasked with implementing the puppy. Now, what he has to do, he can break the puppy as it is, which might be considered an ugly solution, or he has to dig deep into our existing abstraction and touch the dog and the cat again and introduce a bug in there. So it's not that easy and straightforward. So let's do it. These are the parts that doesn't fit our abstraction. So we decide to modify the abstraction. So we remove those things that doesn't quite fit, and we decide that we make the eating part of the action in the abstracted pet. So let's do that. Our pet changed, and now we can update the cat, eventually the dog as well, and we can implement the puppy in this way. So we had to decompose the abstraction, do the change, and eventually abstract this out again. Something similar actually happened to me when I was working on a project with my friend, and he did some great implementation of the code. It was really pretty, not a single repeating line, but the problem is in a month it has to be updated because he found out that it really didn't solve the problem, and the change I needed to do that didn't fit the abstraction, and I had to completely rewrite it from the scratch up to some 3 levels of abstractions, which was very pretty but really rigid and hard to change. So drying is good if the change we want to do fits the abstraction we have. And then it's really good for recommending because we avoid copy-paste bugs using that, and generally the code is pretty, but it increases the complexity. I tend to think about it, the drying your code is like data compression. It's fine, you reduce the disk space, but if you need to search it and possibly modify it, you need to decompress it all. You cannot just look up the important part. So I would recommend that dry the code once we can reasonably expect it won't be touched in the near future before we create some advanced abstractions, and think about what things are you abstracting. I'm very hesitant to abstract out some high-level concepts from totally unrelated pieces of code because it fits the abstraction today. It might not fit the abstraction next month, next year, and then a simple change can be really expensive in the terms of time spent there and the human confusion. We are code writers. Now, I believe we should write the code for the code review. Our audience are another programmers, and one of the very important point in time they read our code is code review. Book authors don't publish their scripts without proofreading, right? So, question is, where are those code reviews done usually? And my experience, most of the code reviews are done into like that. GitHub, GitLab, whatever are you using. Why? Well, it's easier. It's hard to abandon your work when you're doing code review for your colleague, check out the branch, figure out the differences, and then do the merge. This tool does it for you. Furthermore, it allows you to have a discussion for specific lines of code where you don't find something just right about that. But it has an implication. Because your web browser is not your favorite IDE. You only have a syntax highlighting in there. You have no usage find searches. You don't have information about types of different variables. You have no syntax checking. All this neat stuff we are used to have in our favorite IDEs. So with that in mind, there were another recommendation about C++, use almost always auto. When you do that, the code is definitely easier to write, but harder to read. So let's do a code review together, shall we? We have a piece of code here in GitHub, and we want to see if we should merge it. So we have some external functions, foo and bar, taking arguments of unsigned byte, const unsigned byte ref and unsigned byte. And in our main function, we have a lambda, which is completely auto-type, doing an addition. Okay. Then we have two variables, 13 and 42, and we use this lambda to add those numbers together, and we pass the result to foo and bar. Everyone is happy with this code? No complaints? Well, the compiler isn't. We have an error here, which is rather cryptic on line 18, that we cannot pass whatever into that function. So let's take a deeper look. I used cppinsights.io tool for generating this and reduce it a little bit to fit the slides. I really recommend this tool. It's great if you want to see what lies beneath your code, what the compiler actually sees. And here are the important parts. We have those variables or constants, 13 and 42, and as we call the lambda, the add.operator, we get an integer out of it. Why? Because the result of arithmetical operation in C++ is integer. And then we pass this integer into foo, but there is some casting going on, because the foo accepts const byte reference, the compiler does the casting for us, and passes a temporary value to there. It's completely fine, compiler can do it, because const reference extends the lifetime of the things which are given to it. But, we cannot pass our value reference to a bar function which takes byte reference and might modify it. This was completely not clear in the code review, and you might say that this thing should be called by continual integration, and you're absolutely right, but you get the point. How hard was it to find this out in this code? It wasn't trivial to find it just by our own eyes. Usually you have much longer merge requests, and the reviewer eventually gives up trying to understand it to this depth. I can guarantee you this. So, to write your code for a code review, we need to think about how to navigate mind of our readers. And one of these things means not to overuse auto, because it might not be clear. It also helps to keep these merge requests small, because if we have multiple plots in our book we are trying to write as book writers, then it becomes much harder to understand. If you have a novel with a single plot, then it's much easier. Now, I have discussed code reviews from the perspective of the code writer. Now I'd like to focus more on the perspective of the reviewer. What are the code reviews for? Any ideas? Can you show them to me?
Catch bugs early.
Catch bugs early, good one. Some other ideas?
Sharing knowledge.
Sharing knowledge, great, thank you. I completely agree with that one. I would like to remind you here what we know about programmers, and that they don't like being wrong. and they have own feelings and motivations. And remember, the programmer's work is judged in a code review. It can be pretty personal thing sometimes. So I want to show you a code I came across not so long ago. It wasn't in the code review, but anyway, I believe it's absolutely terrible. If you look at how this unique pointer is used, it defies the purpose of the unique pointer, because it has this owning pointer inside the class, and then you put it into unique pointer in some method which may throw. Actually, this comment is taken from the code where I found this thing. So if you found something like that in your code review, you might be probably tempted to tear it apart and complain and get it reworked. But wait a minute before doing that, because be really careful what behavior of your fellow programmers do you incentivize. Jordan Peterson had a great advice: don't practice what you don't want to become. And I want to give a thought to those incentives we give. How often do you find issues in your colleagues' code reviews? Do you just click accept every time you see it? Or on the other hand, you complain about something each time you have a code review? What's your attitude to modern C++ features they might use? Are you scared of them? Because personally, about half of the programmers I know are a little bit scared of modern C++ features and thinking we are progressing too fast with adopting new things. Are you this guy who welcomes new modern C++ features, or are you this person which is overhyped and has to put the cutting edge stuff to your code just to have it there? Do you support creativity of your coworkers, or do you suppress it? It's really hard to change company culture, and while trying to do so, while doing the code reviews, be careful which culture are you actually creating. And I believe that the ugly code, like I showed you, comes down to the problem of picking right bully. Because we are going to be bullied as programmers. I have a bad news about you, and I mean it in this bad, ugly sense of the word. Because there will be bugs and issues in our code. There's no way to avoid it. And we can be either bullied by our coworkers in code reviews, by our customers if the system breaks down in the middle of the night, or we can be bullied by some automated systems. And I really believe it's good to have an automated system saying you that what you're doing is wrong, and it's much better than having your colleagues doing that. Because from psychological point of view, it's much harder to hate that automated system like Clang Tidy than to hate your colleague for pointing out your mistakes. This was my personal experience. So, which automated bullies tools do we have? Continuous integration, of course. Sanitizers, at least 3 of them. Address sanitizer, undefined behavior sanitizer, really great tool. Thread sanitizer, it might be a bit tricky to evaluate that result, but it's good to have. Static sanitizers, I think one which stands out from the line is Clang Tidy. From my experience, the best one you can get. We have fuzzers, who find out the security vulnerabilities and some other issues you might miss by trying to take every possible path through your code. We can introduce runtime debug checks, which is something I did once because I had a system that really very complicated and hard to execute waterfall of arithmetical computations, and there was some bug in there. I was unable to find it, and it had to be executed on this big computational cluster, otherwise it wouldn't manifest. So what I did is I implemented 2 algorithms, one checking the other and telling me when they start to differ. A little bit what they do in the rocket science. They have multiple systems for the same thing. We have tests, a lot of them, and finally we can do things like stage releases and gather telemetry, like do not release your code to the entire user base. If you can do it, just release to a small fraction, monitor it, and then it roll out. You can catch some critical issues much faster this way. So, as was mentioned from the audience, code review shouldn't be about nitpicking. It shouldn't be about finding design flaws. Design flaws should be found before you start coding. Review shouldn't be about stylistic stuff. It should be about understanding the program, because you don't want to be the only person in the company knowing what the code does. Or you don't want your colleague to be the only person in the company knowing what the code does, because your colleague might go on vacation and something breaks and you are required to fix it. And if you have no idea how to do it, well, then you're in big trouble. So, and it should be about understanding the programmers. If you are in some supervisory position, you should know what they need to learn, what they need to become better programmers eventually. As we spoke about incentives of our personal behavior, other things in our development pipeline incentivize certain behavior of humans. Usually the higher the price of doing something, the higher is the incentive to avoid it or to cheat it. You know, the Dieselgate problem of Volkswagen, the incentives were probably badly designed. So what is the cost of running a test? Is it easy? Fine, then it will be probably run often. If it requires a hard and expensive test setup, it won't be done that often. How many merge requests can be merged in a day, depending on your development and testing pipeline? Is it unlimited, or can you merge just one merge request in a day? Because if this is the case, if you are merging just one merge request a day, you are incentivized to having large merge requests with multiple features inside that, and try to review that thing, distinguishing where one feature starts and the other ends in the merge request. So humans usually take the path of the least resistance, and we should design our systems with that in mind. Another topic I want to talk about, helping you to prevent your project from disintegrating, is documentation. And my experience is, I'm not talking about the documentation you ship to your customers with the product. I'm speaking about the documentation, how the thing works. And it's easy, impossible to find, it's outdated, it's non-existent, or it is written in code. And written in code, I don't mean send documenting code. Obviously, your code should be easy to read and easy to understand, but the code, by definition, cannot include the motivations for why it's written this way. This has to be commented. So what prevents you to including several paragraphs of text to the place where the motivations why the code looks like this? I believe nothing. Everyone can do that. I did it. In the past, I even draw some diagrams using text editors, explaining some complex threading issues to make it easier to understand the code below. And if you write your technical documentation like that, it's much more likely to be updated once someone changes the code. Because if it sits somewhere in the internet wiki, everybody forgets to update that thing with the code. If you have it right next to it, it's hard to avoid that, and you can check it in the code review if the person forgot. Issue tracking. I believe issue tracking is part of the documentation. Modern issue tracking system has some token indicating what issue is to be easily searchable, and you can put a comment with that issue number to the code you modified, to that nasty hack you introduce in the middle of the night to make it working, so the person who comes next after you knows why that code is there. You can put that issue tracking number into your commit messages, so you can later find it on GitHub or other tools. And I know that some modern issue tracking systems like Jira by Atlassian support actually having those scanning Git repository and having those issues included in the issue itself. Having those commits included in the issue itself, for example, as a comment. Constraints. as I see it, constants. Constants, as I see it, are part of the documentation. Name your constants even if you use them once. God knows why 13 and 7 are here as constant. But we can put them on separate lines, which allows us to write a comment why this particular value was chosen. And this is more code to write, but it's much easier to read and much easier to document. And constant expressions. If we have some bit flags, like here, well, it's hard to get this wrong, but anyone can tell me what's the 23rd bit flag? What's the correct value of the 23rd bit flag if we do that like this? It's 8 million. It's in neighborhood of 8,400,000. But I don't have to remember that. If I let the compiler do the math, it's actually much easier to check if I did it correctly, and I can make sure that there is an always correct value. When speaking about constants, I want to share with you some trap me and my colleague have encountered that, which cost us a lot of debugging. A nice feature of C++ is that it allows you to put binary constants into your string literals. This can be really handy when doing with some network protocols or things like that. So you put a \x and a hexadecimal number. But anyone guessing what's the size of this particular binary literal array? Aloha, 5 letters, 2 hexadecimal letters, don't forget the trailing 0. One would expect that the size is 8. But it's not, it's 7. Because C++ interprets the highlighted part as a single character. Actually, this thing has still size of 7. Be very careful about that. The solution is to use, that's the part. The solution is to use space operator for concatenating string literals, and then you are fine, and you can make sure that the compiler sees what it's supposed to see, splitting the binary part and the text part. Constraints. As I see it, constraints are also parts of the documentation. We are going to have to wait for contracts at least 3 more years. So I believe normal asserts will survive for quite a while. The huge advantage of normal assertions is that all the system I know of, Windows, Linux, if this assertion fails, it can provide you with information what failed the stack trace, and it tells you that what assertion failed, like how does it look like. What those systems won't tell you are anything around it, like commands. So I would like to encourage you to put your commands inside those assertions, because those string literals decay to pointers. Pointers are not null. This pointer is definitely not null, so it has some positive integer value. Positive integer value is by definition Boolean true. So by adding and to your string literal, you're not changing the result of the assertion. And this is what the system will show you when your assertion fails. Compile type check. I believe constraining things in compile time is the best thing you can do. We have some function foo here taking 2 types A and B. We got this type from somewhere deep in the project, some deep header include, and we have no control about them. But our function has to deal with them, and if we have some assumption about those types, we should write it in static assertion, like checking that these 2 types have the same underlying type in the first static assertion, or in the second that the first type is integral, using the first assertion, the second type as well. And I often write message like check the code below, which is useful. Because if somebody change the underlying type of those types, we get a compile error. If we won't do that, we are not guaranteed to get a compile error. You can get an undefined behavior, which might bite you ugly in some corner case of your deployed application. This technique is particularly useful when doing with generated code. Anyone familiar with Google protocol buffers? It's cool technology. With Google protocol buffers, you have a definition file which is compiled into different programming languages, Java, C++, whatever, and this compiled code you include and link with. So if somebody touches the definition file and changes something, you get a different C++ code, which might break your program, but not in the way you want. So this may make sure that you notice such a breaking change and you get the error message in your compilation. Error handling is not a documentation, but I wanted to mention it here because it really influences the readability of the code. This is error handling by return codes. Let's say we have some function get data which takes URL and it does HTTP request to the meetingc++.com. Now, HTTP request obviously can fail for a number of reasons, and this error handling style is the style from old C. Operating system APIs like to use it, like the like the function in comment. This is the Windows style, and I don't like it. It's really ugly because it forces you to have output parameters. Output parameters are nasty. For once, they cannot be const. We could circumvent that by introducing some immediately invoked lambda, but that's just patching an impossible problem. It's definitely not worth it. From my experience, older and more experienced programmers like that approach back from 90s. We have exceptions of C++, which I don't think this is a good problem to solve its exceptions. Exceptions should be used for something exceptional. Failing HTTP request is not something exceptional, it's a common thing. So that's one reason. The other reason is that having multiple checks like that gets your code really unreadable, especially when they are nested. So C++17 gives us a great tool, which I unfortunately haven't really seen in the wild being used yet, and the code bases, which is std optional, which is, I believe, the correct way to go. The code is nice and the semantics is clear for everyone who is that. C++17 also gives us structured bindings. This was just an idea. I'm not advocating for this approach. Did anyone use something like that or seen? Cool. I didn't expect that. Some hands in the audience. Yeah, this is another approach using tuple and structured bindings. I personally think optional is the better way to go unless you need some fine-grained error codes, because it's cleaner and easier to understand. Now, I'm pretty fast. I would like to show you some practical examples how to make your code hard to misuse. The first technique me and my colleagues invented was inspired by privileges elevation in Linux and UAC in Windows. Let's say we have some basic interface providing some basic functionality in our framework or library, setter and getter, which is safe for everyone to use, even the user of your library who doesn't understand the depths of the system. Then we have some elevated interface inheriting from the basic interface, doing locking with mutexes or some listener management, anything what can break the library. And our implementation then inherits from this elevated interface. This allows us to give the user of the library the safe interface by keeping the elevated interface inside and making it hard to misuse. An example how that thing can be used. We have some engine function and some user function. Engine function takes the elevated interface reference, user function takes the normal one. And we pass the instance to both of them. Pretty easy. If by some good reason a user function needs this engine function, access this engine functionality, they can do that. But same as with operating system, they need to ask for it. They need to ask for more privileges and do a cast to that better interface, which introduces an extra effort the user needs to put into doing that. So hopefully, if the user decides to do that, he or she knows why and what are they doing. Making code hard to misuse at some cost. This is example from Catch, which is a great unit testing framework for C++, originally developed by Phil Nash. And it allows you to write a simple test just like that. You write code like that, define some scenarios, what you give, what you expect, and that things is automatically run. You don't need to care about registering the test for execution and anything like that. It is pretty convenient to use. Now, can we do something similar in our framework? Well, we can. We have an interface doing the stuff our framework wants to do. And yeah, then we have some function. Actually, the problem with auto-registering anything is that first, sooner or later, you run into a fiasco of static initialization. So C++ doesn't guarantee you order in which things are initialized. So to make sure we can use a container, we need to return it from function to prevent some nasty debugging. And in the example class, we use curiously recurring template pattern. We type our parent class to the derived type, and here are two important parts. Create instance, therefore we need the CRTP to get the type of the derived, and some hack to get static initialization, which C++ doesn't support. Static initializers we know, for example, from Java. But with the class we can do it, and if we use static variable, the constructor of the class gets called, and we can use body of that constructor to do the registering for us. So in our child class, we inherit from the parent, we do the stuff we need to do, and here comes the nasty stuff. We need to specialize the template, and we need to define the static member, because otherwise it won't get initialized. After that, if in our main function the initialization gets executed during the program startup, and we can just ask the container for things it stores, create the instance and use it. Now the question is if this is worth it, the trouble, and it's a good question, because this is a lot of hacks which can be eventually hidden behind macros, but it obscures the way the things are implemented. So for a framework like Catch, for unit testing, where you are likely to give it a lot of test cases and you are really not interested in the internals of the framework, it might be. If you have just a few things, probably not worth the additional complexity. And for my last example, where I believe the cost was too high, there is a problem with STL. because the STL forces you to break encapsulation of your iterators. If we have some implementation class of some interface which we want to design, and we want this to be iterable, to iterate with the hidden container, we don't really have much choice. We have to put the container type into the interface, which is not good. We might change the container type in the future for something different, for example, from vector to list, because vector invalidates its iterators once you add some new values to it. So you cannot really take a pointer to those things in the vector, because the vector can reallocate and your pointer just points to the middle of nowhere. But STL won't allow you, there's no abstract interface for iterator. So one way to go around that problem is not to expose those STL-like iterators, which are really convenient, for example, for ranged force, but to expose a function which does the iteration and accepts the lambda. It can be used like that. This way we keep the container type hidden without exposing it to user, but it's a lot of inconvenience in many cases. The other possible approach would be to create your own iterator, somehow hiding the real one, which is what we actually did, but that rabbit hole I won't show you because it's really deep, really ugly, and generally it wasn't worth it. So I would like to close my presentation with my spoiler slide. When you invent some neat trick that helps you to have a cleaner code, think about your audience, think about the programmers, think about how it affects them, and if it isn't actually counterproductive. I would like to thank to my colleagues and friends, Hanka Dusíková and Pavel Šrámek, because they encouraged me to do this and work with me on some code which is basis of what I show you in this presentation. Thank you very much. Do you have any questions?
Hi, first of all, I've seen many of the things you've mentioned in the wild, and so very good presentation, thanks for that. I would like to add that one of the customers of who's reading the code and the documentation is oftentimes yourself. We've all come back to code that we haven't seen for 3 months. So please keep that in mind and your own personal habits.
I completely agree with that. Thank you. I heard a quote like that: documentation is a love letter to your future self.
Hi, thank you for the talk. In the beginning you claimed that we should think about that we write the code for future reviewers, right? So code guidelines also claim that they make life easier for reviewers. And do you think code guidelines or coding according to them is a good idea, or is it just another tool to bully coders? And if yes, do you have any opinion on which one you would prefer?
Well, there are many code guidelines out there. Some of them contradict themselves or the other guidelines, so it's always hard to pick the correct one. And I think when you choose a code guideline, it's too good that the guideline to be enforced by an automated system. Because if it's enforced by some of your colleagues, some of your team members won't probably like that, and you are increasing attention. So it's definitely the way to go, but be careful. What way do you choose to enforce those guidelines? If you can enforce those guidelines by Clang-Tidy, for example, I think Clang-Tidy can enforce some like Google guidelines. It comes with pre-programmed guidelines. You can certainly program your own. Then it's much better and much easier.
Okay, thank you.
But this is my personal opinion.
Hi, thanks for your talk. Regarding your STL slides, I would like to ask...
Which slide?
STL, about iterators. So why don't you use template return type? It will hide the actual type of the container.
Well, it's hard to use templates combined with virtual methods generally. But if you're interested with it, we can discuss it later. I'm not sure whether C++ allows you to use templates with virtual methods. I don't think so.
No, it does not. I'm saying that you had functions begin and end. So why don't they return T, template T, iterate, and
because those methods are virtual. And
I see.
They cannot be templated by C++. That leads to another really deep rabbit hole. And I believe I asked this question on Stack Overflow about 10 years ago and got one answer. So that you can look it up. It would lead to really nasty things down here in C++, and therefore it's not allowed.
Okay, thank you.
I think the term is template covariance. Yeah, the term to search for. I might be wrong there.
Yeah, I have a question about code reviews and designs. I'm not sure if you were completely against reviewing designs during code review, but certainly not a friend of it.
I think the design part starts and should end before the code is written. So you should gather with your colleagues before you start writing the code to design it, and then you shouldn't be surprised in the code review.
I very much agree, but writing code increases your knowledge. So usually we don't have the luxury to implement 2 or 3 prototypes and then decide on the actual design. So usually programming also is part of prototyping. So I end up with a design which might be imperfect.
Okay, so what would I do is if I found out that the design needs to be changed, or if during the writing of the code or something I didn't expect, I would consult and speak with my colleagues and not to have them surprised in the review, because I believe it's too late. Because if they don't like it, then you're in conflict and you have problem because you are heavily invested in that merge request you're trying to get merged, because you spend so many time working on that.
But I think that's the actual root cause of the problem. Why are we as a group, as developers, identify ourselves so much and our self-worth so much with that pull request? Because I think there lies the actual problem.
Well, being less egoistic about your own code would certainly help, but I think everyone can agree with me that it's the harder part of self-development.
But you can work on it.
Sure. Thank you.
Hi. I would like to ask whether you have some suggestions about how to keep big pull requests small. Like if you implement a huge feature, I mean, would you merge early on and then have like a half-finished feature, or what to do about that, basically? Either you have a really huge thing in the end, or...
I understand. Again, this is personal opinion. Sometimes there's no way around it. Like some features are just big. You can decide whether to split that feature can be split into smaller ones, which is okay, but I don't think those smaller features should be incomplete. If you decide to split it into smaller features, the feature should be somewhat self-contained and not some dysfunctional change waiting for the future work, because the future work might be delayed for any number of reasons and might not come at all, and now you're stuck with a bunch of code which just sits there and is of no use. So if you can make your merge requests smaller by splitting them into sub features which can stand on their own legs, so to speak, then it's fine. Sometimes you have no choice but have a large merge request. But I would recommend, the larger the merge request is becoming, sooner speak with your colleagues about it and not to leave it just for the review and have them by a big surprise.
So I have a feedback regarding the large
merge request and
Please.
also goes to the design reviews. So one practice I found really working is before you implement a big feature, share it with your colleagues on a like a public review. Do a public review with your colleagues so you can discuss design, and then there are no surprises when you do your merge.
Absolutely agree. Programming starts on the whiteboard and on paper, not in your IDE.
Well, first, sorry for bullying you with nitpicks in code reviews. I should have learned my lesson from that too. And second, I have more of an observation than a question. You mentioned something interesting, that the web interfaces for code reviews are not IDEs. Well, is there any practical barrier why there shouldn't be? Shouldn't we pressure GitHub developers to add more IDE-like features like show usages? Or shouldn't we standardize a format to export from GitHub and load into an IDE to do the merging in the comfort of all this automation?
Well, if you can convince GitHub, our authors, to implement such feature, I will certainly not complain. I think there are some IDEs, and I might be mistaken, I think some IDEs from JetBrains support something like merge request inside them, but most of the IDEs don't. So to have better support on the tooling part in the web browser, it would be great. Thank you. So, no more questions. Thank you very much.